Okay, here's Unit 2, Day 4, and this is probably something you've never seen before. It's called a piecewise, or we're going to do piecewise functions. And really, it looks more complicated than it is. What it is, instead of just having one function tell you how to do the whole graph, now we have two functions. One function if you're on the left side of a certain line, and the other function if you're on the other side of a line. So they get to be kind of some crazy shapes. But on this one, well, I guess we'll do our learning target here. So learning target, I can write an equation for the graph of a piecewise function. And I can also evaluate and graph piecewise functions given an equation. So the definition for a piecewise function is a function with different rules for different parts of the domain. So like here's an example of one. This says evaluate the following for f of x. So it says function x. Well, it all depends what x is. Here's this rule. If x is greater than 4, plug it into here. So take it times 3 and subtract 5. But if x is less than or equal to 4, plug it in here. Okay, so like if I'm going to do 7, first got to figure out is that greater than 4 or less than or equal to 4. And since that one's greater than 4, I would take 3 times 7 minus 5. Okay. So it's all, look at this first, figure out what rule does it follow, and then once, what part of the domain is it in? Is it greater than 4 or is it less than or equal to 4? And then plug it into the function that corresponds to it. So here 4 is not greater than 4, it's equal to 4. So I'm going to use this one. So 4 squared would be 16. And then for negative 3, well, negative 3 is less than 4. So it goes in the squared one. So it would be negative 3 squared, which is 9. Okay, so this guy, new one here, now this has 3 different parts to it. So if x is less than 1, plug it into here. If x is between 1 and 3, then the answer is 3. And if x is greater than or equal to 3, then plug it in here. So double it and subtract it from 6. Okay, so it's just, like I said, don't overthink it too much. I mean, I think sometimes students look at this and they get overwhelmed. Take that number 10, figure out which rule does it follow. Well, it's greater than 3. So if it follows that rule, plug it in there. So 6 minus 2 times 10, and that'd be a negative 14. Where does 2 fall? Well, 2 falls between 1 and 3, so the answer is 3. There's nothing to plug in. There's no x, so that is the answer. It's just 3. That's like having a y equals 3 right there. So it doesn't matter what x is, y is 3. And then f of 0, figure out where does 0 fall? Well, 0 is less than 1, so plug it in here. So negative 2, absolute value of 0 plus 1, and that gives you a negative 2. Now we're going to evaluate this guy here. So evaluate it for different input values, same idea. So plug in 10. Which one does it follow? This guy right here. It's more than 0, so 10 goes into this one. So 0.5 times 10 minus 1. Okay, that'd be a 4, because this would be 5 minus 1. Negative 10, what is negative 10? Where does it fall? It's less than 0, so plug it in here. So 2 times negative 10 would be negative 20. Okay. How about 0? 0 is right here. 0 equals, so this is the only time you plug it in. The only time you add 5 to it is when it is 0. So that'd be a 5. 0 plus 5. And then 2.48. Where does 2.48 fall? Well, 2.48 is greater than 0, so it goes here. So 0.5 times 2.48, and then subtract 1 from it, so it would be 0.24. Now the next guy, kind of working backwards now. They've given you the answer. Like this answer was 4, this answer was negative 20. Well, here the answer is negative 6. They want to know what you plug in. So P of what would you plug in to get negative 6? So you gotta work backwards here with it. And the biggest thing here, it's kind of tricky. You say, which one should I use? So I see this as, I was recording and something messed up here, but the largest this could be would be close to 0. So it's any negative number and double it. It could be in there. So these could be a lot of negative answers. So like negative 1 is less than, that's negative 2, negative 3, negative 4. If I keep putting bigger negatives in, I double them, get bigger negatives. So it could be in that area. This here, this only works if x equals 0, and if that's true, that's 5, so that can't be, because that doesn't equal negative 6. The last one then, I can only plug in positive numbers. Okay, so this here is asking for positives. Just make sure my microphone's working. Yeah. So if I'm plugging in positives, taking half of it and subtracting 1, I can't get to negative 6. There's no way to have a negative 6. This, like the very smallest I could would be 0. That'd be a negative 1, which isn't close to negative 6. So the only one that could possibly come out for an answer is this guy. So if I plug in, what number do I plug in? So 2 times what equals negative 6? That means x must be negative 3. So negative 3 is your answer. Okay, the next one, it says Braylon wants to join a gym. If he joins for 7 months or less, it'll cost him an initial fee of $40 plus $12 per month, including that first month. If he joins for more than 7 months, it'll cost him $130 for the whole year. So if this represents the months, first month, second month, third month, complete the table to figure out how much he'll have to pay. So if he joins for 1 month, then he'll have to pay $40 for initial fee plus the $12 for that first month, so it'd be $52. If he went for 2 months, it'd be the $52 here plus 12 more, so it'd be $64. And we're just going to keep adding $12 every month after that. Okay, and we get up to $124. If he joins for more than 7 months, so right here it switches over. So 7 or less, we follow that model. Now after that, it's just going to be a straight up $130 for the whole year. So 130, 130, 130, 130. Okay, so they waive that initial fee if he buys the whole year at once. So if I want to write a piecewise function for this, well, first off, my breaking point, my x values, what are my rules? Well, for my either x is less than or equal to 7 or x is greater than 8. So that's the breaking point. It's 7 or less. 7. Let's say 7, more than 7. So it's 7 or less, and then greater than 7. So then what are the rules? Well, this one's kind of easy. It's just $130 no matter what. No matter what x is, $130. We could actually, maybe I should put this, since we're going up to 12, we should say that x is between 7 and 12. So I should put that technically to be 100%, if we're going to be very specific. And over here, all the way up here, I kept adding 12 for every month. So for every month that passed, I added 12. And what did I add 12 to? I added 12 to that $40 initially. Okay. So that's just like how to make a real life problem out of a piecewise function. So if you're going to graph this guy, and again, I'm not going to be super specific here, but for the first month, you're going to pay $52, and it's just going to keep going up and up and up and up. But if you made it to 8 or more months, it would flatline. So there's 2 pieces to that. Okay, so backside, let's look more at graphing here. Again, look at the rule. It's like here the rules is 4. 4 is kind of the breaking point. So it might help you to just either draw this in or just mentally put a line in there. So at x equals 4, there's a line. If you're on the left side of that, so if all the x value is less than 4, you follow this function. And I'm going to graph that. So if I want to graph this guy, I'm going to graph over here somewhere this guy. And then at 4 or more, I might do a different one. Okay, actually, this one's going to be negative. It's going to be going down a little bit. Okay, so I think the easiest way to kind of start out with is, the way I do it anyways, I want to know where on this line does this first function start. So I'll do that by plugging 4 in. If I plug 4 into this function, it tells me where to start on this graph. So 4 times 2 is 8. 8 minus 5 is 3. And that is going to be a closed circle because it's equal to. So closed circle. And from there, I have a slope of 2, positive 2. So that means I want to go up and to the right, but I'm supposed to be going left because it's for x values less than 4. So I'm going to go down 2, left 1, down 2, left 1. And I should cross at negative 5. That's the y-intercept. 1, 2, 3, 4, 5. Yep, that's it. So that's that piece. Now the other piece is, if x is greater than 4, what do I do? Well, where do I start on this line? Let's find out by plugging 4 into that function. So if I plug 4 in, negative half of that is negative 2, plus 6 is 4. So it's going to start here at 4, open circle, because it's just greater than. And then it has a slope of negative 1/2. So down 1, right 2, down 1, right 2, down 1, right 2. It goes something like this. Okay. This guy here, a little bit faster here. You've got at 1, there's one of these lines. And then at 3 to 10, there's more of these lines. If you notice, let's see, 1, 2, 3, 4, 8, 9, 10. Yeah, that's over here. There's no rule for if x is between 1 and 3. That means there's going to be no graph in between there. So there'll be no graph in between these two lines. There's just nothing. On the left side of 1, I need to graph this. So let's plug 1 in and see where to start on this dotted line. So if I plug 1 in, 1 times 2 is 2. 2 minus 1 is 1. Open circle. From there I have a slope of 2. So down 2, left 1, down 2, left 1. Goes something like this. Again, nothing between here. If I want to find out for 3 where to start on here, plug 3 in. So 3 minus 3 is 0. And that's a closed circle because it's equal to. And now plug 10 in to see where it stops over here on this line. So plug 10 in there. 3 minus 10 would be negative 7. So 1, 2, 3, 4, 5, 6, 7. Open circle because that's an equal to. I'm sorry, that's not an equal to. It's just a less than. Okay, so there was no definition, no rule for if x is between 1 and 3, so we have no graph between 1 and 3. Now below, I would say pause the video and just quiz yourself real quick, see if you can do it. And you could definitely narrow some things down, like for number 13, it's supposed to match which one of these is that graph. Well, the boundary line's at 1, so I need to go through and find out which ones have a boundary line at 1. So this is 4, 2, that's a 1, so it could be A. I'll just put that down. This one is at 1, so it could be, I guess I skipped a few here. B can't be because that's a 0. Here the boundary line's at negative 1, so it could be D, could be E, and that's it. So it's one of those 3. So any of them that has a 1, I'm looking over here, this could be A, D, or E, and this could be A, D, or E. And I'll just throw out the ones. So this one says if it's less than 1, it has a, or actually I just plug that in, so I can plug in 1. 1 minus 4 is negative 3. So where does the left graph start at negative 3? Well, this looks like it's at negative 4. That's not it. This one, it should be, let's say negative 3. That's not it. And then this one does start at negative 3 and goes left to the slope of 1. Closed circle. So that one, E is the only one left. So that one's E, which means these one, they can't be E. Let's go to number 15 here. So it could be A or it could be D. If I plug 1 in here, that'll tell me where to start on that boundary line. If I plug 1 in, that'd be at 1. So I should be starting at 1, and that is not starting, that's in the negative, so that's not starting at 1. So it can't be A, it must be D, which means this one can't be D, and it must be A. So maybe pause and try the rest. I'm going to just put the answers down here in a second, but try to pause and see, could I do these on my own? Okay, and see if that helps you do it.